This video, we're going to look at merge sort. We're going to go ahead and type in the merge sort, and then I'll create a main to test it, and then we'll create a main to analyze it. But merge sort uses recursion in order to split the list in half down to where it gets to a place where it can actually do the sort, which is 1, and then it merges them back together again in the right places. So we'll go ahead and get started with this. In our merge sort, we're going to pass in a list. So we're going to start off with our base case. If the length of a list is greater than 1, then we're going to find the midpoint, which is going to be equal to the length of a list, integer division 2. Our left half is going to be equal to a list colon mid, and our right half is going to be equal to a list mid colon. Then we're going to call merge sort on the left half, and we're going to call merge sort on the right half. So it's going to take the list, break it in half, 2 parts, the left half and the right half, and then it's going to do a merge sort on the left half. So do the left all the way down till it gets to the end of that, and then we'll come back and then do the rights all the way down. Okay. Then when we get those done, we're gonna have to put them back together again. So we're going to set z equal to 0, j equal to 0, and k equal to 0. We do a while loop here. While z is less than the length of left half and j is less than the length of right half, if left half z is less than right half j, a list k equals left half z. Z then plus equals 1. Else a list k equals right half j, and j plus equals 1. And then when we get done with all that, then we're going to do a k plus equals 1. Next while loop. So while z is less than the length of left half, a list k is going to be equal to left half z. Z plus equals 1, k plus equals 1. Another while loop. While j is less than the length of right half, a list k is equal to right half j, j plus equals 1, and k plus equals 1. Okay, so what's happening here is that this is merging them together here. This part up in this while loop here, that's what that's doing, is merging the two here. And then if there's anything left over in the left half and the right half, it puts those back in there. Okay? So if it merges and then you end up with one that's greater that hasn't gotten put in there, then that's what happens there. Okay. So let's do a main to test it out. Do a small list. List is going to be equal to bracket here 4, 6, 1, 8, 2. Well, let's print this out here first. And then merge sort our list. And then we're going to print the list again. Okay. So get this running. And there's my first error. Misspelled merge there. So let me find where that is. It's going to be one of these two up here probably. There it is right there. Another one there. Left half, so A list K. Right there, I left the T out. There we go. So there's our list unsorted, and there's our list sorted. Okay. So small list. Let's try with a bigger one. Actually, a few bigger ones, and we're going to do some analysis with timing on this. So we're going to put input, and I'm not sure if we need the random, but I'm going to put it in there anyway. Random and import time. Okay, so I'm not going to do anything in here to change any of that. We're just going to change our main down here. And like I said in my other video, when I did on shell sort, and I'll show you this here in just a second and get the right location for it. Here's the folder that I'm keeping this stuff in. And I have 3 text files. One is called numbers 10,000, numbers 100,000, and numbers 1,000,000. And so those were files that I created that I randomly selected numbers, put them in there, and then shuffled them on there. So what we're going to do now is use that in order to test our program here. Okay. So I'm going to start off with a list. Then in file equals open numbers 10,000.txt. Opening this up for a read. Then we'll go through a for loop for num in file. List.append num. So we get all the numbers in there. They're already sorted for us, so I don't have to worry about that. Close our in file. I'm not sure. I'm going to go ahead and put this in here just in case I didn't shuffle those numbers. I'd have to look at them to see. But random shuffle list, and then we'll start our time. Call merge sort. Passing in our list. get our end time, and then print out the results. Do I already have a main on here? Yes. Okay, let's see what happens with this. So for 10,000 numbers, it took 0.076 seconds. And if you remember from the shell sort was a little bit quicker than this. It was 0.06. So I'm going to go ahead and change this in here to my 100. And change this to 100. And we'll run it again. Oh, got an error. Let me double check and see what I called that, because I thought I had that right. Oh, I didn't put the 1 on the front of it. Sorry about that. Numbers 100. So this one takes 1.06, and I don't remember exactly what the other one was, but I know it was over 1 second. I think it was 1.8 or 1 point, something like that for the shell sort. And we're going to run it one more time for the 1 million. And this one's going to take a little bit longer because million is quite a bit bigger. That took 12.7 seconds. And if I remember right, on the shell sort, it was 14 seconds. So this one isn't much faster than the shell sort, and this one uses recursion, which has a little bit of overhead, or actually quite a bit of overhead, with the stacks from calling the merge sort for the left half and then merge sort for the right half. So it takes the stacks all that in there. So shell sort up to this point looks like it's pretty decent compared to this. So next video is quick sort. So take a look at that if you're interested in the shell sort or in the quick sort. Bye.